The Krebs cycle and associated diseases.
Krebs cycle is an endless series of metabolic pathway followed by glycolysis. It takes place in mitochondria and it consists of 8 reactions. The Krebs cycle starts with condensation of acetyl-CoA and oxaloacetate to form citrate. Second step of Krebs cycle. Citrate is rearranged to form isocitrate. Next step, isocitrate is oxidized into alpha-ketoglutarate. The fourth step, alpha-ketoglutarate is oxidized into succinyl-CoA. Succinyl-CoA is converted into succinate and GTP is formed as the product. Succinate is oxidated into humarase, forming FADH2. At seventh step, humarate is forming marate. At the last step, marate is oxidated into oxaloacetate. This oxaloacetate can be used for first step.
Now we're going to talk about several diseases related to the Krebs cycle. In this cell, alpha-ketoglutarate dehydrogenase complex is operating normally, converting alpha-ketoglutarate to succinyl-CoA and producing CO2 and an NADH.
But what would happen if something were to go wrong?
Enter thiamine deficiency. If your body cannot uptake thiamine or you don't have it in your diet, for example, if you're an extreme alcoholic, then your alpha-ketoglutarate dehydrogenase complex is missing an important cofactor, thiamine pyrophosphate. So the non-thiamine dependent enzymes can be decreased in activity by thiamine deficiency, either because of the oxidative stress caused by lack of thiamine, or because all the enzymes of the Krebs cycle are grouped together in a metabolon. In the case illustrated here, the non-thiamine dependent enzymes regain function, so we're illustrating the oxidative stress hypothesis. The pyruvate dehydrogenase complex, once deactivated by losing the thiamine pyrophosphate, cannot be reactivated. This is what happens to your brain if you're a severe alcoholic. First, you'll get Wernicke's encephalopathy, and your thalamus and hypothalamus will start degrading. And then later, you'll go into Korsakoff syndrome, and you'll keep losing your memory, and eventually you'll die.
Succinate-CoA synthetase is involved in step 6 of the Krebs cycle and is involved in converting succinate to fumarate. Succinyl synthetase deficiency is caused by a deletion mutation in the SUCLA2 gene. This gene encodes for the beta subunit of the ADP-forming succinyl-CoA synthetase ligase. This mutated subunit causes reduced activity of succinyl-CoA synthetase, which results in a buildup of succinate in cells with this mutation. Symptoms include mitochondrial DNA depletion and encephalomyopathy. MTA DNA depletion causes mitochondria to no longer be able to reproduce. Mitochondrial encephalomyopathies are disorders in which muscle and brain tissues are affected. The most common example of this is Leig's disease. This degenerative brain disorder is usually diagnosed at a young age in children. Deterioration is often rapid with symptoms such as seizures, dementia, feeding and speech difficulties, respiratory dysfunctions, heart problems, and muscle weakness. Prognosis is poor, with death typically occurring within a few years of diagnosis.
In step 7 of the Krebs cycle, fumarate is converted to malate with the help of the enzyme fumarase. The gene coding for the fumarase enzyme is located on the long arm of chromosome 1. It spans 22 kilobases and has 10 exons. A mutation in this gene is known to occur that leads to a mutant fumarase. The mutant fumarase is incapable of converting fumarate to malate and leads to a buildup of fumarate in the cell. This hereditary condition leads to several problems, including leiomyomatosis, or cutaneous leiomyomas, cancers in the skin. Around 10% of patients that present with this mutation end up with renal cell cancer. Uh-oh.